We're going to be talking about bits, bytes, and binary in this lesson. So, what is binary? But before we can talk about binary, we need to know about how a computer talks. So, computers contain a large collection of tiny switches called transistors. Each can be turned either on or off. So, bits are the language of computers. Each flip of the transistor is a bit, or binary digit. So binary is on or off, yes or no, true or false. So it's 0 or 1. So an idea is computers only understand electrical signals. So once a transistor receives a signal, it turns on or it turns off. That is it. And that's the binary number system. Okay. So for example, in this, say the average song on iTunes is 32 million bits, 93 million bits for a 5-minute video, 4 billion bits for a Microsoft Office program. It might be a lot of different things. So 4 bits are called a nibble and 8 bits are called 1 byte. Okay, and that is how all of our data is stored, is as in bytes. Kilobytes, gigabytes, terabytes, so on and so forth. So humans don't know how to communicate in binary. So we write code, and then the code that we write gets thrown through a compiler, and then it changes it to machine language or puts it all in binary so the computer can understand what to do. We're not watching any of these videos. We're just going to go through this. So how does a computer recognize what letter you want to press on your keyboard? So what it does is it takes the binary number. So when we press the letter B on our keyboard, for example, it puts it into binary. So it figures out, hey, this is the number 66 in decimal, and then the ASCII character appears as the letter B. And that's how we know. So in decimal number system, it's a base 10, and that's our counting system that we use, 0 through 9. There's 10 digits there. And anything larger than 9, we add another number to it. So we only have pure 0 through 9 as numbers. Okay? So binary is the base 2 number system, zeros and ones. Okay? So on or off. So if you notice here, there's some numbers now on the top. Okay? We're going to look at those. Remember that a byte has 8 bits. So binary numbers use these 8 position values. By placing the values into a conversion table, we easily convert from binary to decimal numbers. So here we have our regular numbers 1, 2, 4, 6, 1, 2, 4, 8, 16, 32, 64, 128. So if we look at this number here, 0, 1, 0, 0, 1, 1, 0, 1. What number or what letter is that? Or what decimal number? We need to figure out the decimal number. What decimal number is that? Well, how you figure it out is you just look at this table. Oh, 64 has a 1. So I know that's a yes. 8, 4, 1. So we add all those up together and we get the number 77. If we do it again, 128, 4, and 2. So 4 and 2 is 6 plus 128, we get 134. That's how you figure out from binary to decimal. And the largest number you can have is all of these be ones, and that's 255. So we're going to quickly look at hexadecimal. Hexadecimal is, we know our base 10 system, 0 through 9, but base 16 is A through F on top of 0 through 9. So you can have a number like this. F3 is a hexadecimal number. So we're not going to spend too much time in hexadecimal, but just to give you an idea. Okay, and then here's, if you wanted to do that, how you would figure that out. Okay. Encoding. So encoding in computing is used to represent a range of characters by some kind of conversion system. Okay, so you're just converting. Okay, that's not encryption. So we're going to see a couple different slides here, and each slide at the bottom here, you're going to see the word cybersecurity encoded in that system. So here, this is cybersecurity encoded in binary, which we know binary is 0 and 1. Here it is in hexadecimal. Here it is in base 64. So not based on a number system, it uses 64 printable characters and a formula. So it uses A through Z, capital and lowercase, 0 through 9, plus slash. So it uses some characters, some symbols. Okay. And then here it is in MD5 hash. So hashing is applying an algorithm to data input. So no key is used. So the hash can be decoded by anyone using the correct algorithm. So there's different types of hashing algorithms, MD5, SHA-1, SHA-256. Okay. So let's look at cryptography concepts. Cryptography, scrambling data so it looks like Babel, so nobody else understands it except the intended recipient. An algorithm, or the cipher, is a precise set of instructions that tell the program how to scramble and unscramble data. Plain text is the decrypted or unencrypted data, so anybody could read it. Ciphertext is data that has been encrypted, and cryptanalysis is attempting to break a cryptographic system. Okay, so we have substitution and transposition. Substitution is changing from one letter to a different letter. So, and we're going to go look at that here in a second. And then transposition is changing the order of items. Okay, so here, let's look at the Caesar cipher. This is an example of that substitution. Okay, so here you just choose a shift. So right now the shift is 2. So you figure it out. So this plain text is bead, but when it's converted, it's ZCYB. So you just go back to 1, 2, and you get B, 2. You see what I'm doing? Okay. And there's different websites that have something like this for you guys to work with and try to solve and figure out like what this says. Okay. So common words. So you're going to look for common letters, vowels. It's all going to help you out. One-time pad. It's unbreakable because it switches every like 60 seconds or 20 seconds, whatever you guys have it set up to be. And it's a different combination of characters every time. Okay, and then transposition. It's the order of the letters are changed, and you have to put them all back in the order and try to figure out what the word is. And then you have this. I'm not going to try to pronounce that because that looks French. It's a polyalphabetic cipher, substitution based on multiple alphabets. Okay, so. And then you guys have a lab. You have 2 labs. You have one assignment, which is breaking ciphers, and then you have the steganography lab. And I'm going to do another video recording explaining how to do steganography.